Our next speaker. Dr. Stephen Vettermann is here from PROSTEP, where he is manager of systems engineering and verification and validation. Within the set-level project, he is the coordinator of all PROSTEP's activities, not only for set-level 4 to 5, but as well for verification and validation methods. And furthermore, he is the key responsible for traceability for the traceability demonstrator, which is named Tracy. And that is exactly what his presentation today is all about. So a warm welcome to you, and it's your stage, Stephen.
Thanks a lot for that kind introduction. And also from my side, a warm welcome from cold and rainy Hamburg. So today in the morning, we got a lot of information about set level overall concepts and the application in the simulation use cases. In this session, we are filling with live what was introduced, and now it's my pleasure to draw your attention to something very interesting, traceability. And the PROSTEP traceability software demonstrator, Tracy, which implements in set level project what's specified there, and also enhancements coming from the requirements from the V&V project, but we will have an overview of the V&V project later on. So following leading standards, like for example, ISO 10007 for configuration management and ISO 24765 systems and software engineering, traceability is relating artifacts, means that one links information that belong together and sustains the resulting network of information. But providing a traceability software means more. It means to create and maintain the information network as much as possible automatically, and of course to offer added value to the users, assuring compliance by distilling and storing information, guiding users through dedicated processes like companies' best practices, ASPICE, ISO 26262, or the credible simulation process, and for revision safety. Furthermore, for driving efficiency, for example, to offer transparent searches over manifold repositories to foster the reuse of existing information, as well as to support collaboration by offering exchange possibilities based on neutral standards, and to handle complexity, enabling users to perform impact analysis, to track, steer, communicate changes, and to control maturity of whatever is created within the process. Finally, safeguarding the quality, supporting users in performing their tasks with the right information, and to check consistency and completeness. So, of course, traceability and the tool within set level has to build on top of the introduced methods, respect the presented processes and formats like the credible simulation process or the credible modeling process, and the underlying and created within that context corresponding neutral XML formats. Especially the simulation task metadata format, the STMD, or the simulation resource metadata format, the SRMD, and others. I will come to that point later on when giving an insight into Tracy itself. And we got to support the shown set level use cases, but of course, not only them. So currently, we're driving forward this undertaking in close cooperation with the experts in set level and V&V. And to cook this great meal, one has to consider what I just introduced very briefly. We need the methods introduced in the morning. We need to consolidate the processes in set level, especially the credible simulation process. and flavor this together with a huge know-how which we have within the set level project, and to distill all this into an integration platform. That's our mission, more or less. So Tracy is not yet another database. Tracy creates added value to the users by linking information in arbitrary databases, systems, and information that does not even have a home, like all the Excels we have, paper notes, and whatever. And we enrich this with additional information, embed this into the context of interest. So for that level and the V&V methods, project PROSTEP is realizing a neutral web-based demonstrator to make this happen. It links artifacts, persists the relationships between them, as well as metadata and rationale. And by the way, rationales are, for example, remarks by a creator of the information, assumptions while modeling taken, all these tiny pieces of information that normally are not documented, but which are important, for example, when deciding about reuse of a model. Additionally, visualizing and filtering the information, and the network is a cornerstone of Tracy. For example, to support change impact analysis, coverage analysis, as well as project status analysis. And additionally, Tracy fosters process efficiency and a neutral data exchange based on the XML formats coming with the credible simulation process. So with Tracy, we realize traceability, that's a value for sure, but it should not be the end in itself. We use traceability to generate added value, and in Tracy, this is implemented in modules. Here you can see on what we are currently working. So we offer traceability and very close related topics like the impact analysis, configuration management, and baselining. But also we are fostering the reuse of information, quality improvement, maturity control, change management, reporting, revision safety, and auditing, as well as enabling the communication and the collaboration within and also across organizations. So this forms the heart of Tracy. The user interface is web-based, but the power lies in the underlying part, where different connectors allow to integrate arbitrary information sources. In this context, we support standard-based, industry standard-based, but also proprietary interfaces. Of course, for that level, we integrated Git because that's our source of all our information. But for example, for integrating doors, we are also C. That's also not a problem, and it's already done. To give you just some examples or a glimpse inside what we are currently realizing. We are not copying information, we are referencing them and create trace links between. How? I will tell you later on. And yes, we are preparing interfaces to orchestrate Tracy into the greater context of companies, so that, for example, project or workflow related information can come from other systems. So at the end of the day, with Tracy, we are generating a digital thread shown here as this tiny red line over a set of configuration items. Starting with the simulation goals and the derived list of requirements, passing on to architecture decisions, models, and the user simulation environment, or the used simulation environment, to finally to support the documenting of the simulation, the results, the decision making. We offered to link all of the arbitrary artifacts along this path. In set level, this path is steered by the credible simulation process. And we use this intelligence to auto-connect the information that belong together. This forms the technology basis for then offering the impact analysis and communicating changes, create reports, and so forth. So traceability can be used to ensure that all the decisions are known and all decisions can be traced and documented. This ensures, from our perspective, that all the requirements are met and tested. In addition, we offer the possibility to check every development step and every change against the requirements, just as to raise some examples. But now let's dive into Tracy. Originally, we planned to do this presentation from the studio in Munich, where no internet connection is possible, so we prepared this presentation as an offline presentation. So I brought with me some screenshots and we'll go through that to demonstrate how the realization in Tracy is done. This is, by the way, the first time that we present Tracy in front of such a huge audience. And just as a remark, currently we are preparing a complete redesign of the graphical user interface. So next time we will present it, it will look different. Let's phrase it like this. We will enhance the look and feel and the usability and further develop, of course, the functionalities shown in the following. What you see here is the dashboard of a specific user. In this case, I'm now Jane P. Miller, a project manager, and the dashboard allows me to interact with Tracy via different entry points, either by selecting one of my projects or to search for a specific task, artifact, and so forth. Or I'm starting from my cockpit where all my tasks and responsibilities are presented. And of course, if I, as a project manager, want to specify a new project, I can use process templates to front load and to start easier to do this. Currently, we offer as templates, of course, the support of the credible simulation process, but also the credible modeling process, because this is a basic requirement within the set level project. And as manager, I can also incorporate new users, new partners, and so on. So let's jump into the list of the projects in set level. What you see here as first outcomes is the list of the simulation use cases following the CSP, means the credible simulation process, and the OZ pedestrian model realization following the credible modeling process, the CMP. One can create projects from the scratch or by using process templates, but also one can add a new one by copying or reusing another project already existing, so for repeating projects. Or in collaboration scenarios, one can import projects via the neutral STMD format. I already mentioned that for a quicker front loading to get a better and quicker setup to create the projects. These opportunities help the user to plan and document their projects and their tasks more efficiently. So if we pick, for example, the simulation use case 1 in set level, we see the project following the credible simulation process in all its phases and tasks. On the left side, you see the structure view, and I can use to navigate through all the different stages of the process, including all the tasks. We see the general project information on the more right part and the main part, with all the basic information like the project ID, project manager, start and end date, and all this stuff, followed by the graphical visualization of the generated information network in a graph representation. One can dive into this, but also by using various filters if one is interested in seeing only specific information. So let's imagine that we want to know if a change of a specific requirement impacts other projects. For this, we can just click into the graph presentation and select a specific requirement here. And we can directly perform impact analysis. If we want to perform, for example, reuse analysis, so let's just filter for projects. And hey, what we see here as a result is that the requirement does not only influences the simulation use case 1 we just saw, it also influences the simulation use case 2 and the simulation use case 3, and additional the OSI pedestrian modeling realization. So we picked a fundamental requirement. Of course, these analyses are not only possible for requirements. We can do this for any kind of artifacts. So requirements are one, but also models, scenarios, and so forth. All this managed by Tracy. It's possible to perform various kinds of this kind of impact analysis, as shown in the example, even across the different projects. So let's jump into that OSI pedestrian artifact. Tracy links the information in the set level Git, shown by the source repository GitLab. And what we see here then is that we have an auto connection between the information which is stored within Git with all the relevant metadata, status information, and so forth. So you should, or you must not be able to read this tiny web browser slide, but more or less what you see here is a direct connection between what's handled within the set level Git and what's handled within the Tracy implementation. All these informations can here be viewed, but also searched and edited and so manipulated. And relevant information are kept in Tracy, and especially the metadata in this simulation resource metadata file format. We can read and write this information. And by the way, this is coming, as said before, coming along with the credible simulation process. And that was this direct connection between Tracy, and this file format was also additional requirement from the set level community to realize that. Good. So, but where does the interrelation of these different artifacts coming from? What is the basic traceability tracing mechanism? Of course, one can do this manually. As you see here, there's a tiny in the main navigation bar the possibility to direct link every piece of information managed by Tracy. But to be honest, that does not make fun. It's not really efficient, and in real life, it's even not really credible. So we take the advantage from the logic behind the credible simulation process and implemented a specific business intelligence. And at the end of the day, while users are guided through the process and work on their task, we do auto tracing. We can see here in the upper right part the button request work. So what we've done is to implement a tiny minimal release process to support workflow management and to support or to realize also the credible simulation process. You see the responsible user or engineer performing a task, and also the approver then who has to check this kind of information. By the way, you also see here the release state of the current information, when is a task to be started and when a task should be ended. This also helps to control the maturity of a phase or a task or an artifact, to inform users about changes, necessary actions, etc. We implemented a messaging mechanism similar to the functionalities you may know from systems like Confluence. And you see here these tiny bells where then the messages pop up that certain things should be done, or informations are handed over to a specific user who is then responsible to do whatever is needed. And finally, at any time, we can create baselines and reports, immutable documenting of the status and the referenced artifacts for a project at a certain time. We currently also work, just an additional information, on concepts to respect long-term archiving requirements. That's a field where we gathered much beyond 15 years of experience together in customer projects. Good. To sum up my presentation, so with Tracy, we support the requirements coming from that level, especially concerning the engineering and the testing of safety critical systems. In that level, for Tracy follows the credible simulation process and the set level methodology. And Tracy forms, therefore, a smart information network of all the different information currently gathered within the set level project. And we offer also this instant to every partner within the set level project. For doing this, we are respecting the relevant standards and also offer neutral data exchange of the beyond lying neutral data XML schemas. And as final information, of course, PROSTEP will transform Tracy into a software product and offer this to the market after the project's end. So thank you very much from my side, and I'd like to give back the word to the session moderators.
Yes, and that's me. Thank you very much, Stephen, for your interesting presentation. And it is again Jochen who I am asking to read up or bring up the questions from our audience to Stephen.
Yeah, thank you, Verena. So you gave already the answer to the most important question that was put: how will Tracy be available to use? What is the license model behind it? When will it be available? Maybe you can elaborate it a little bit more. Or is there even a first prototype that is available before the end of that level?
So currently we offer this to every participant within the project. And we are currently working on providing a publicly free available instance of Tracy. And for sure, we will offer that then to the market, and also based on several concepts. We're currently working on putting the whole stuff into the cloud to also address this kind of requirements. We are somehow bound to the conditions of the consortial contract, but we're currently preparing the market, the going to market of what we are currently creating there. So to be honest, maybe also an earlier outcome of the whole thing is impossible.
Okay, thank you. Now there is an interesting question. How do you deal data safety, encryption of data, and prevent data manipulation?
So that's one of my favorite topics, because I wrote my doctor thesis exactly about this this section of IT security. So we are incorporating we are hashing the whole stuff what we referenced. Also doing the digital fingerprinting so that there is no manipulation on that. And of course, we're using the state-of-the-art security mechanism, accessing the different data stores, but also then what we put on our platform to encrypt that. So that's more or less, it's huge work, let's phrase it like this, but we are that's one of our one part of our concepts when we started to respect exactly that, because that's critical information that shouldn't be changed, and also sensitive information, so it should be protected with what's state of the art of the security mechanisms.
Okay, thank you. So next question is, we have seen that the credible simulation process is pretty well integrated into Tracy. So is this directly implemented, or could you also think of integrating any process into Tracy, and how could this be done?
So Tracy is set up very flexible. It uses and supports the CSP, the credible simulation process, but it's not bound by any restriction to that. If you like to, you can come up with any kind of process. We have also requests from participants. Is it possible to have, a 2-step or 3-step approach, and to, to build this structured view in a more our company-like style, and then to provide this kind of information? So that's possible. We are absolutely flexible. We are not bound to that. But especially within that level, we respect that for sure. But if you like to have a completely different process, for example, you want to just theoretical example, you just want to steer your ASPICE process, it's absolutely possible. Just pump in the correct template, and then you have it.
Okay, maybe a final question.
Yes.
What are the next steps regarding Tracy and that level?
So next steps, as already mentioned, is getting more re-engineering the graphical user interface, getting the whole thing into the cloud, and of course to implement more connectors to be more flexible. Would be, for example, when we are also already in discussion with the colleagues, for example, from DSpace, how to integrate what they just introduced, what we just heard. So to get a more variety of the different information. So that's the from the technical perspective what we want to do, and on the other hand, of course, we want to have the product ready whenever it's possible.
All right. Thank you very much, Stephen.